Lesson 6-3, adding and subtracting fractions with like denominators. And in this lesson, you learn to add and subtract fractions with like denominators. And when are you ever going to use this? You'll add and subtract fractions with like denominators when you work with equal parts of a whole, such as sections of a garden. Let's take a look at this example. John prepared an area of a vegetable garden. He used rope to make a 3 by 5 grid of squares, okay, of corn in 2 squares. How much of the garden has he planted so far? Again, let's reread the problem. Okay, he used rope to make a 3 by 5 grid of squares. He planted green beans in the back 3 squares and corn in 2 squares. How much of the garden has he planted so far? So we can actually identify with this problem by creating our own little garden on grid paper. Okay, so on grid paper, draw a rectangle like the one shown. Since a 3 by 5 grid has 15 squares, each one represents 1 out of 15. So this is our 3 by 5 square, and one of these little grids will represent 1 by 15. So one of these, okay, will be 1 out of 15. Okay, so with a colored pencil, color 3 squares to represent the 3 green beans. So let's use a colored marker on our part. Let's use brown, okay, and it says there with a colored pencil, color 3 squares to represent 3 green beans. So 3, okay, this one right here will be good. Not working, so we'll just use, let's undo that, and let's use crayon. That better. Okay, this will represent the colored pencil a lot better. So with a colored pencil, color 3 squares to represent 3 green beans. Let's use green. 3 green beans. So this is our 3 green beans right there. Using our crayon. There you go. Okay, with a different colored pencil, color 2 more squares to represent the corn. So we'll do it in black, represent our corn. There you go. Okay, done. That's done. Okay, how many squares are colored? 1, 2, 3, 4, 5 out of 15. So there would be 5 squares are colored. What fraction represents the number of colored squares? Obviously 5 out of 15, right? Or 1/3. If you color 4 more squares, what fraction would that represent? So if I color 4 more squares, and let's use this color right here. No, that's not crayon. Undo that, baby. And then use this. And use a different color. There you go. 1, 2, 3, 4. Okay, what fraction would that represent? And that would obviously represent 9 out of 15. Okay, because there are 9 squares shaded, or simplest form is 3/5. Okay, so what does that tell us? Basically, fractions with the same denominator are called like fractions. Again, when you define like fractions, they are fractions with the same denominator. You add and subtract the numerators of like fractions the same way you would add and subtract whole numbers. The denominator of the fraction names the units being added or subtracted. Okay, so let's take a look at what we did in the mini lab. We know that 3/15, okay, plus 2/15. So 3/15 is this one. Add 2/15, that'll give us, okay, 5/15 or 1/3. Okay, so here John has planted 1/3 of the garden so far. So let's go to the definition of adding like fractions. To add fractions with like denominators, add the numerators, use the same denominator in our sum, and that's exactly what we just did. Let's take a look at example number 1. Find the sum of 3/5 and 4/5. Again, we use estimation, okay, to find out if our answer makes sense or not. So we estimate 3/5 to become 1/2 and 4/5 to become 1. So our answer should be close to 1/2. So let's take a look at this one. We have 3/5 and 4/5. They have the same denominator. We simply add the numerators together. We end up with 7/5 or 2 and 1/2. Okay, and let's take a look at the model and see if our answer makes sense or not. So we have 3/5 right here. Okay, and we're adding 4/5 because these are our two wholes. Okay, divided into fifths. So 3/5 plus 4/5 will give you how many fifths? 1, 2, 3, 4, 5, 6, 7/5 right there. Okay, so right there 7/5, counting 1, 2, 3, 4, 5, 6, 7. That's 7/5. And if you notice our two wholes, 7/5 is also the same as 1 whole and 2/5. Okay, right there. Okay, and in the same manner we can subtract like fractions. Okay, so subtracting like fraction, we come up with this rule. Well, it's probably in the next page. Yes, it is. Subtracting like fractions, to subtract fractions with like denominators, subtract the numerators, use the same denominator in the difference. Okay, so subtraction has three meanings. Each of these is shown in one of the following examples. So take note of the meaning of subtraction. Okay, first meaning of subtraction is to take away part of a set. Okay, so the second meaning is to find a missing addend. Remember what an addend is? When you have two addends, that makes a sum. Okay, so when you talk about an addend, let's just review an addend. Okay, plus an addend will give you the sum. So in the meaning of subtraction is to find a missing addend. So what you find one of these addends, and the last meaning of subtraction is to compare the size of two sets. Okay, how do we do that? Let's look at the following examples. Okay, so take away part of a set to find a missing addend and to compare the size of two sets. So Reiko opened a carton of milk and drank 1/4 of it. How much of the carton of milk is left? Okay, so since 1 is equal to 4/4, you need to find 4/4 minus 1/4, because 1 carton of milk is 1, and you can rename 1 to 4/4. Why 4/4? Because 1/4 has a denominator of 4, and we need to find a fraction with the denominator of 4 which is equal to 1, and that's 4/4. In doing that, you are able to subtract like fractions. Okay, so you have 4/4 minus 1/4, or 4 minus 1/4, and that'll give you 3/4. Okay, so 3/4 of the carton is left. Let's take a look at example 3. Patrice was refilling her water can. The can holds 7/8 gallons of water. If it took 5 gallons to fill it, how much water was already in the can? So if you look at example number 2, this talks about taking away part of a set. And let's see what example number 3 is in terms of the meaning of subtraction. Okay, so Patrice was refilling her water can. The can holds 7/8 gallons of water. If it took 5/8 gallons to fill it, how much water was already in the can? Okay, so you can use mental math to solve this problem. Okay, you want to find the value of x plus 5/8 will give you 7/8, and that gives you the second meaning of subtraction, to find the missing addend. Okay, so this is an addend we want to find. So x plus 5/8 will give you 7/8. Okay, and think what plus 5/8 will give us 7/8. And since we know that when you add or subtract like fractions, all you need to do is add and subtract, okay, the numerators and keep the denominator the same. So basically what it's saying is that what will you add to 5, which will give you 7, and still keep the denominator the same, okay? And that would be obviously 2 eighths. 2 eighths plus 5 eighths equals 7 eighths, but we need to reduce 2 eighths to simplest form, which is 1/4. So the answer is 1/4 of a gallon, okay? And finally, example 4, okay? Again, we discussed the two meanings of subtraction. The last meaning of subtraction will deal with to compare the size of two sets. According to the 1990 census, about 12/100ths of the population of the United States lives in California. Another 7 out of 100 of the population lives in Texas. How much more of the population lives in California than in Texas? Before we continue, the secret word for this particular lesson is cranberries. Okay, let's continue. Okay, so how much more population lives in California than in Texas? So you have, since you have 12 over 100 lives in California, you do 12 minus 7, because 7 over 100 lives in Texas. Okay, subtract the numerators, and you end up with 5 over 100, or 1 over 20. So about 1/20th of the population of the United States live in California than in Texas. Okay? And that is to compare the size of two sets. That is our fourth example, and we just demonstrated the three meanings of subtraction with these three examples. All right, the lesson's done. Thank you for watching.